Greenhouse gases. We know they damage our environment, but do we know which of these greenhouse gases is the most potent? We've got carbon dioxide, methane, and nitrous oxide. Well, the answer is nitrous oxide. Nitrous oxide, otherwise known as N2O, is a greenhouse gas that is 300 times more potent than carbon dioxide. This means that if you have 1 pound of nitrous oxide and 1 pound of carbon dioxide, the nitrous oxide will warm the atmosphere about 300 times more over a 100-year timescale, a significant difference. In addition to its potency, its long life in the atmosphere of about 114 years makes nitrous oxide a dangerous contributor to climate change. And global nitrous oxide emissions are on the rise, largely due to our strained food systems. So let's talk about it. Today, we will first look at where and how growing food results in nitrous oxide emissions. Then we will discuss how we, that means me and you, can reduce these emissions through policies and individual actions.
Nitrous oxide is a potent greenhouse gas released primarily from agricultural activities. Fertilizer use is the main source of human-caused nitrous oxide emissions, but livestock and poultry are also responsible. Nitrous oxide is emitted from the breakdown of animal manure and from the fertilizer used to grow the animal feed. In the US, China, and India, nitrous oxide emissions are primarily the result of the use of synthetic fertilizers. In other countries with emerging economies, emissions of nitrous oxide are growing alongside crop production and livestock numbers. Did you know that Brazil is the world's largest producer of cows, with over 200 million cows in a country of just over 200 million people? While much of this beef is consumed within the country, Brazil is also the largest exporter of beef in the world. Beef that ends up in the stomachs of people in the US, Russia, Egypt, China, the EU, and many other countries.
So, how does nitrous oxide end up in the atmosphere? One of the biggest sources of nitrous oxide emissions is agricultural soil management, which entails manipulating the amounts of nutrients and minerals in the soil for optimal plant growth. Simply put, soil management often means applying fertilizers. 2 processes are responsible for nitrous oxide emissions from soil management. 1 being using synthetic fertilizer, and 2 being applying fertilizer over the amount that is required for the plants. Fertilizer, which contains nutrients like nitrogen, is applied to the soil so plant roots can take up those nutrients. These nutrients are used by the plant for different functions. For example, nitrogen is important for photosynthesis. Because nitrogen is critical to ensure high yields of many crops, farmers will apply a lot of it to get the highest yield. When this fertilizer is over-applied, plants are unable to absorb all of the nitrogen. Then, microbes in the soil will consume the excess and convert it into nitrous oxide, which is then released into the atmosphere. So, over-applying, which is a common practice to increase yields, can lead to more harmful nitrous oxide emissions. Synthetic fertilizers can amplify this problem as they have higher levels of nitrogen and other key nutrients, making it easier to apply too much of one nutrient. And these nitrous oxide emissions will interact with global warming and climate change in a so-called positive feedback loop. As more nitrous oxide is emitted, the greenhouse gas traps heat in our atmosphere, and the global temperatures increase. As temperatures increase, more nitrous oxide is released from the soils, thus looping back to trap more gases and increase temperatures even more in a repeating cycle. Moving on to the next big emitter in agriculture, let's consider manure management. Manure again provides nitrogen to microbes, which then release nitrous oxide. This is particularly a problem when large amounts of animal waste accumulate and are treated. In addition to fertilizer and manure, there are other nitrous oxide sources that are worth noting. For example, transportation of food and production of machinery or chemicals used in agriculture contribute to nitrous oxide emissions. These sources can be seen in this chart, showing they are responsible for a significant amount of emissions, but they are relatively small when compared to agricultural soil management or manure management.
Since we know about 3/4 of nitrous oxide emissions are coming from agricultural production, we need to support policies to reduce emissions. We can support farm practices that use less nitrogen fertilizer and look to use legume crops, which add nitrogen to the soil, and rotational grazing instead. Other farm practices include reduced tillage of the land and using cover crops to protect the soil, which will decrease the breaking down of organic matter and thus the release of nitrogen or nitrous oxide. Also on farms, applying fertilizer at multiple times throughout the crop season increases efficiency of use by the plants. We can ask our governments, universities, and farm businesses to support farmers who want to research these and other methods to reduce nitrous oxide emissions on their farms. More broadly speaking, we are concerned with the rise in nitrous oxide emissions linked with increased food production to meet demand for food as the global population continues to grow. But did you know that roughly a third of the world's food is wasted, and in wealthy countries like the US, much of that waste occurs in the household? A study published by the American Journal of Agricultural Economics found that the average US household wasted 31.9% of its food. At the household level, individuals like you can work to reduce food waste, to do their part in reducing emissions in the food system. Reducing how much food we waste can reduce how much food we need to grow, and that in turn reduces how much fertilizer we apply and how much manure is produced. By taking the time to plan and prep meals for the week, you may find less food ends up in the trash, whether it be less food you have left over after meals or less food that spoils in the kitchen. Remember that within the agricultural sector, animal production contributes to 65% of global N2O emissions. 65%. There are also ways to shop more sustainably, like looking to reduce consumption of animal products and enjoy plant-rich meals instead. If culturally and financially feasible, think about consuming chicken in place of beef. To summarize, nitrous oxide, or N2O, although less abundant than carbon dioxide and methane, is an extremely potent greenhouse gas. Its concentration has been rapidly increasing, mostly due to large-scale farming with synthetic fertilizers and livestock production. We are concerned with concentrations of the gas because it has been shown to stay in the atmosphere for a very long time, typically about a century or more after its release. We are living in a very important time in which we are finally seeing policies being created and pushed to address this greenhouse gas. And so, with your support, we hope to see a future that continues to decrease nitrous oxide emissions.